Hey, hi Aditya and hi Mukesh.
Good evening.
Good evening, sir.
I'm audible, right? Yeah, cleaning. So happy to meet you all once again. And of course, I may forget at the end. Wishing you all a happy Diwali.
Yes, happy Diwali to you.
Yeah,
Thank you, sir.
yeah, yeah. Aditya and Mukesh, you can ask your doubts. So
Yeah, let me ask the question from the graded assignment 4. Okay.
Graded assignment 4.
Yeah, can I share my screen or can you open it so that
Yeah, sure, please do. Yeah, anything is fine. I think.
we are not allowed to share the screen, I think.
Okay. Yeah, now I just shared
Yeah.
it. Week 4, right?
Oh, yeah.
Okay. Yeah,
This first question. Okay. I understood that the function has 4 minima because I can see in the A, B, C, D, we are going into a minus direction. So we have the contour, the cutting points are in minus. So it is going to reach to minimum. Okay. But in the positive side, which as the question has given that there should be a one maximum. So how you are know that it is going to maximum because this -1 and 1 and in the E point, it doesn't have given any value, means it is going to 0 or it is going to be some value. So how you are determining if it came in
so one approach is that I look at all the all the points which are either maximum or minimum. Then, as you said, right? So if I have a surface, something 3D surface like this, then I have to take some level cuts across the surface, right? And that's how we plot these contours. So when I look at this level cuts where the values are constant, and when I look at them each of them, then I can see that for all these points, right, A, B, C, D, it keep on decreasing. Okay, so I am starting from some, say for example, z is equal to say minus 1.8. I'm not able to see that clearly. Maybe I can show you. Yeah. So you look at here. So we are seeing a value of minus 1.8, minus 1.6, minus 1.4. So what does that mean actually? What these values actually implies?
So it is cutting the slide, and as it we are going into the minus direction, so we are going into the minimum. Because from minus 1.2, we are going to minus 1.2, I think 1.8, which is the less value, right?
Yeah, so it's not like we are going from minus 1.2 to minus 1.8. By the way, the better way of viewing this is, right, I have some 3D surface with X, Y, and then Z axis. Let's say Z is kind of pointing upward. Then I start with the value of minus 1.8, right? Because I'm setting Z is equal to minus 1.8, which produces a constant XY plane, right? That passes through better I can draw the diagram instead of drawing it in an app. Maybe since it is 3D, it might be quite difficult for me to draw exactly.
No problem. Just I want to know the concept.
So we are this is X and this is Y. So how do we actually take contours? Now my surface is in 3D. So first I have to produce a constant Z plane at different values, right? And by looking at the diagram, I'm seeing a value of minus 1.8. That is the minimum value that I can see from the entire contour diagram. So, which means that I am actually generating a plane that is an XY plane, right? So this is actually an XY plane positioned at Z is equal to minus 1.8, right? So then it cuts the surface there. Whatever the surface there, it simply cuts across the surface. Then that is what we call the trace of this path as contour, right? So you are able to follow. You are able to follow.
Minus 1.8, you are telling it is just a plane. And
Sorry,
the
minus.
X and Y value will change, but Z is going to be fixed at 1.8, right? It's a plane cut.
Yeah, it's a plane cut. So we are fixing it at minus 1.8. An XY plane is there, then it cuts the surface. If there is a surface, then it cuts across the surface. Then if there are some path on the surface, right? So once it cuts across the surface, then it generates some path, maybe a pure circle, or depends on the curvature of the surface. We have some complicated curves. So which means that if I am seeing some point here, right, the surface something look like this, okay, and this is the minimum value I can infer from the diagram. Then all these values are minus 1.6, the other values are minus 1.6, and then minus 1.2, then 0, and then 1, and then 2. So like that, I keep on changing this XY plane from minus 1.8 to all the way up to some 1 or 2, whatever the value I want. Okay. Then for all of these values, we are plotting these contours. And then after plotting these contours, then you can infer this, the trick that the distance between the contour is actually, it conveys the information whether the slope is steep or eccentric. So these are all next thing. Yeah. So these are all the next step that I have to look. But the first step is what are all these numbers, first of all. So minus 1.8 actually denotes that my z value is minus 1.8. Then I have this xy plane that cuts the surface across, keeping z is equal to minus 1.8. So if I have any value there, you can see there is some circle there, right? Which means, and also the circles, you can infer that the gradient is also changing across the contours, and the value of the surface itself is minus 1.8, and then it must be now I am thinking it's a minimum. Unless I look at the other values, I can't say whether it is a minimum, by the way. And minimum doesn't imply it has to be 0. So that's why we have to check other possible values. Then I am checking all other points marked on this contour. Then I see that all of them are minus 1.6 and minus 1.6 and minus 1.8. So there are two values at minus 1.8 and minus 1.8, and there are two more at minus 1.6, and I think that's also minus 1.8. So I can conclude that these are all minimum, because if I look at here, that the one are you able to see this arrow that I am pointing here?
Yeah, I can see.
Yeah, okay. Yeah, so when I move from here minus 1.8 all the way on the contours, okay, so my values are actually increasing from minus 1.8 to minus 1.4, minus 0.8, and then minus 1, and then it becomes positive 0.6. Okay, then there are some other values. Okay, but what I can see is that now I am actually moving on the surface, not I am going below. From B, if I move away from the B, actually I am moving on the surface, because my contour values are the surface values itself is increasing. So which says that I am actually moving towards some hill. Then I am repeating the same step from all these 4 points. When I move across the contours, and all of them are actually moving up. So I can see that these contour values are positive, meaning that at z is equal to 0.6, when I said the, maybe these here, is not. Okay, this is z value. Okay, then I have xy plane here, which actually, if I have some surface, something like this. Okay, I'm just trying. Then it actually cuts the surface there. Okay, so the contour of that constant, I'm having contour of something like this with values equal to 1.6. Okay, I'm very sorry about this. Okay, 1.6, meaning that though it's not exactly the maximum point. Okay, so if I have some surface like this, I'm not actually asking you whether it is exact maximum point. Okay, so but I know that I am actually moving towards the maximum from the minimum. So by comparing all these contour values, and also studying how the slope changes, and also noting down that whether I am moving up or down, then I can infer that these 4 points are minimum and the other point E is the maximum. Okay, I'm not exactly saying that is the point where the maximum occurs, but I know that must be a maximum.
Okay, understood. One more thing, when we are telling this, the cutting of the jet plane, it is cutting the entire surface. It is not that for A, it's a different cut, for B, it's a different cut, or C has a different cut. When the plane is cutting, it is cutting the entire surface, and then it is either going down or going to be up, right?
Yeah, I understand that. What do you mean by cutting the entire surface? When I, so I think I can use that same. You interact with that applet in this slide. I think I removed that.
No, that I think it's a video, I think. Yeah, I tried different functions, but I am unable to get that similar functions.
Yeah, actually, we tried with some GeoGebra applets. Actually, we wanted to illustrate all these ideas with one GeoGebra applet. Then we made a mistake. Actually, when we record, while we record the lecture, we realized that we made a mistake in the applet. So we switched it to a different applet. That's why we were not unable to explain how this contours are actually generated. Even the professor attempted to explain that, but anyhow, if you haven't encountered that before, then it might be difficult to understand. So let me, of course, I'm going to show you one applet, but that's not the correct one.
If I will get the
but sorry, give me a second. It's loading. Yeah. So now we have a 3D surface, right? What I'm going to do is I'm going to you are seeing I'm generating a constant plane by changing the values of z. So when I said z is equal to 0, that is actually an xy plane, the entire xy plane. Keeping z is equal to 0 and varying all the values of xy, it generates the xy plane. Now it cuts the surface at that point. Now I am changing the values of z to, say, for example, 0.1. Okay. Now I have again an xy plane that actually placed at a constant position of z. So it is the entire plane. Now it cuts the surface, right? Then it generates this contour on the surface. Okay.
Are you showing something?
Wherever it actually intersects the surface.
Are you showing any other thing except your drawing board?
Oh, sorry, sir. Yeah, I'm showing it. Sorry, I think I have to switch this. Sorry. Where is that? I think I have to share this one. And so, otherwise, it's like a.
Yeah. No, I can. Yeah.
Yeah. So here you can see that. So now I have a surface, right? So you just imagine I have some kind of surface where we have one maximum point. Of course, that's a global maximum. Now, what if I want to generate a contours, now we have x-axis, y-axis, and the upward axis is z-axis. What should I do first? I have to, in order to generate a contour, first I have to create a plane. Now I'm creating a plane which is passing through the z-axis. So
okay,
when I said levels equal to 0.1, meaning that I'm setting z is equal to 0.1 and vary x and y, it generates an xy plane that actually passes through 0.1, right?
Okay.
Geometrically. So maybe I can choose a different. Now you can see this, right? Now I have a plane that actually passes through z-axis at 0.7. Okay. Now you can see that, right? And also it cuts the surface.
Right.
So the point of intersection is marked as a contour. So whatever the point it cuts across the surface, then it generates some path around it. We call this as a contour, right? Then as I keep varying it, now my level is equal to 0.8. So it is actually a contour generated by cutting this 3D surface by an xy plane placed at z is equal to 0.8. Or you can say that is the surface with value 0.8. Okay, I mean, if you measure the value across these contours for all the points, then it is 0.8. You know the reason why, because I am cutting the surface at keeping z
Right.
is equal to 0.8. So all the values are 0.8, right? So by looking at these values only, I can infer whether I'm moving towards the maxima. So we can do this for various values of z, and then we can project it down to xy plane. That's what generates the contour.
Yeah. Just one question. Suppose the way
all
you
the contours
made
are
one graph, suppose there is one more graph is there, like same way it is going. So when the contour will cut, it is going to cut the two in the same, the level 0.1, both are cutting in the same way or both have a different, this level value.
So you mean what do you mean by one more graph is going at this?
I'm telling you made this graph, right? Suppose there is one more, you can say one
this
more.
is one function, f of x comma y. You mean f1 of x comma y. Let's say I have f of x comma y, which is this cute hat. What do you mean by one more graph? I have one more function, f1 of x comma y.
No, I am what I'm trying. Suppose we have one more maxima also along with this. So I have one more maxima. Again, we are making one maxima. So now when we are putting this level 0.1 or 0.2, when it is going to be cut, it is going to cut the both the, you can say, heights, right? Or both the graphs.
Yeah. No, it has to cut. So it's this xy plane is actually infinite in both the extent, right? So if there are, more, or if there are maximas, then this xy, since this xy plane itself is infinite, it has to cut across all the surface that it touches upon, right? So if there are more than one maximum, then all of them will get, cut across by this xy plane, but all of them will have the same value. Say, for example, if I keep this levels equal to 0.7, then I see contours with 0.7 marked on those contours. If I see more than 3 contours, right, or more than one contours with all of them equal to 0.7, then I can conclude that there are 3 hills, but I'm still not sure whether all 3 of them are at the same level unless I look at the other contour values, right?
But you suppose your level values are very different. Then when it is going to be cut, for example, suppose then how you are going to do, means how it is going to be cut and how you know that, okay, because one can maybe reach to minima, but other it is happened up to halfway. So in that case, how we are going to know that it's reached to minima or not? Are you getting my question?
Yeah, so I'm yet unable to get your question. So this is the, here I can generate a number of, say this, let's take this example.
Yeah, you take this example, right?
Yeah, this is the example I actually used in the question. Okay, so now from looking at, of course I can't show you these z planes, but now you understand how we generate the contours by generating different planes positioned at different location along the z-axis, right? Now let's say I have two. By looking at the surface, I know I have 2 maximums, okay, and then 2 minimums, right?
Right.
Now I want to draw a contour map for this surface. Okay, so what should I do? So let's say, since I know the maximum values, say my values are, my function values, the range for the function is, let's say I keep it from -2 to +2. Okay,
we can equally distribute with some range, and then we can cut.
Yeah, so I have to generate, because since I know the range for the function exactly, now I'm going to generate a contours.
Okay, I got it.
So now I'm setting some values here. You can see that, right? Now I create a contour, which means I move xy plane position that -1, and then whatever it cuts across -1, you can see contour.
Okay, got it. Understood.
Right? You are seeing -1 here. Yeah, so from this I can say these 2 are minimum, these 2 are maximum. They are going to minimum, they are going to maximum. I don't say this -1 is the maximum. Actually, the maximum value. I'm just saying these contours represents the maximum, the hill, and these contours represents minimum. That's all.
Yeah, understood. So based on the range it is cutting, so anyway it is going to means take the range correctly and it will divide. Okay, Got it. Thank you.
Yeah. So yeah, of course you can interact with this applet which is there in this slide, and also you can see after we make these cuts, the contours are actually platted on the surface itself. Then we are projecting it down to XY plane.
Okay. Actually, the circles are showing for every up and down in separately. So I thought that these all are cutting in a different way. But as you told, it's in the same scale it is going to be cut. Then I think it's okay. Okay, understood. Thank you. Now the concept is clear.
Yeah. So, thanks, Mukesh. Yeah, and if you have any other question, you
So question number.
Ask,
can
then
ask, or we can move
too many
to audit.
questions.
Yeah.
So question number 5, sir. Look ahead value. Week 4.
Okay. Yeah. So, do you see the questions I displayed here?
No, sir.
I think I have stopped share. Okay. Okay. So, which week assignments?
Week 4.
Week 4. So the same. Okay.
So look, question of 5.
Question 5. So did I share the solution of this assignment? I think I shared it. Okay, by the
Yes, sir. You
Wait.
said the solution,
this
but
is question.
yes, sir, this is the question.
Okay. Please go ahead, Aditya. Please ask the question.
Sir, we have to calculate look ahead value.
Yeah.
But in calculating look ahead value, so when we see the code, there is 2 things that we have to calculate for W and B for both of them. But when we will write answer, it is actually taking one answer. So that is the confusion. So can you, sir,
So I
can you share the code, sir? It was in the slides.
okay. Give me a second. Maybe. So it's week number 5. It's Mr. Accelerated. Or, taking some time. Yeah. Maybe that's slide number. Yeah, so this is the code for the NAND.
Yes, sir. Look ahead. So we have to calculate DW and DB both.
Of course, yes.
So we will have 2 answers for this.
Sorry, I am not able to understand your question, Aditya. So we are calculating look ahead.
Yes, sir. There's 2 things. One is DW.
Yeah,
and
another one is DB.
Yes, sir. But there is answer. So there will be 2 answers, no?
Yeah, we have to actually update the compute DW and DB. Then have to use these 2 values to compute the look ahead. Okay, so maybe I can. I mean, were you able to understand the solution, or do you have? Okay,
Sir,
let me explain the solution
okay.
first. If you are not able to understand the solution, I am explaining the solution first. Okay, then again, if you are not able to understand that, you can pinpoint which part you are, you know.
Okay, sir.
Oh. Fifth question, right? Yeah.
Yes, sir. Yes, sir. Fifth question.
So anyway, let's forget about that code. Let's pay attention on this look ahead computing. I mean, computing this look ahead value. Okay.
Okay, sir.
Now, unfortunately, I'm not able to write on this slide. I am using
Okay,
this
sir. Okay, sir.
arrow
No
to
problem.
pinpoint. Okay.
Okay.
Yeah. So now I have to compute this omega t minus, wt minus beta ut minus 1. That is what we call it as look ahead, right?
Okay. Yes, sir.
Computing the gradient at the look ahead is different from computing the look ahead. You understand that part, right?
Oh, sir, but look ahead is actually the gradient of W. Gradient W. DW. We are
No,
calling.
no. Look
No, no,
ahead.
no. Right.
No, look ahead is W alone, right? So this, whatever the argument that I am passing to this nabla operator is the look ahead value.
Yes, sir.
I am not, I mean, okay. So first thing I have to compute this WT and BT. That's what I need to compute. WT minus beta, UT minus 1. So I have given you these values.
Okay.
U9, W9, all the required values. And also I mentioned what is the value of B9 as well. So what you are essentially doing is first you have to compute this one, WT minus beta UT minus 1. So I'm just replacing this entire operation by this prime. I think that's not a big deal. So I'm just substituting the current WT value, which is 2.5. Okay, WT means I actually asked you to compute at 9th iteration. So which is 2.5.
Yes, sir.
And then beta value it's constant 0.9, and ut minus 1 is also given, right? So it is 0.8. So it's 1.78. Okay.
Yes, sir.
Now I computed the value for 1 parameter WT, and then I have to repeat the same to compute the value for BT.
Yes, sir.
So you substitute the value, so you end up with minus 0.72.
Yes, sir.
So these are all the points where I need to compute the look ahead. I mean,
Gradient.
I have to move on this search space or the parameter space 1.78 and to minus 0.2. I have to move to that point, and then I have to compute the gradient at that point, right?
Yes, sir.
You are able to follow up to this point.
Yes, sir.
So then now we are looking ahead and computing the gradient.
Okay.
Then what is that confusion you have in your mind now?
So we
now
are calculating a gradient with respect to W or with respect to the B.
No. I don't know why you are calculating the gradient. See, in our update rule, what we have, what this delta WT actually mean? The grade. We always compute the gradient of the parameter with respect to the loss. So I think this is one of the common confusion among many students, right? We never compute gradient with respect to B or with respect to W.
So gradient.
I mean, they are local gradients. Okay, let me show you this code now. Maybe you can understand. Unfortunately, we have this formula grade W and grade B.
Yes, sir.
Okay.
So grade W is with respect to W, gradient with respect to W, and grade B is gradient with respect to B. So in answer, we are calculating with respect to
So
W.
what you have. So you computed values for sigma x into 1 minus sigma x because we used sigmoid function.
Yes, sir.
See, that's actually wrong.
Sir.
I don't know, I have this future in whiteboard.
Oh,
Maybe I can start from here. I see many of you are quite confused about this notation.
Even in discourse, I have posted and you told, then I realized the mistake.
Yeah. So
sir.
because in deep learning we use so many notations, and that kind of often leads to even if you are not careful about why we make calculation, we tend to make mistakes all of a sudden, despite we.
Actually, this gradient W, when we are telling
So
it's
we
respect
have this.
to loss function, not respect to W or D.
Yeah. You keep this in your mind whenever you touch this subject, deep learning, right? So we always compute. If we don't mention anything, we just mention the parameter, means that we are actually computing gradient with respect to loss. I mean, loss with respect to that particular parameter, not local gradients, any local gradients. Okay, Aditya, we have this equation, right? Maybe Wt plus 1 equal to Wt minus eta. This pen is, we have this Wt, right?
Yes, sir.
This is general stochastic gradient descent, general gradient descent. So what this gradient of Wt actually means? How do you compute that?
So this is
no matter what optimization, yeah. Are you computing the gradient with respect to the current W?
Yes, sir.
Okay. So what if I understood correctly, what you are saying is this current W, since we are using sigmoid function, we end up using this formula sigma x into 1 minus sigma x, right? Did you use this formula to compute the gradient? Okay. So actually, when we write this nebula W, we actually mean that we are computing the loss with respect to, computing the gradient of loss with respect to del W, right?
Yes, sir.
You are able to. So that means we have this entire formula. Actually, we have to compute gradient all the way starting from the output layer, right? So we have, since we have single sigmoid neuron here, we have only one neuron. So we have to start by computing the gradient of loss with respect to the output, that is dou L by dou Y. Then we compute the loss with respect to this neuron, and then we go all the way up to the input. The entire formula is like, in words, I can write this as, we always start with computing error. I mean, gradient of loss with respect to the output layer, or in general just the output, and then we do back propagate. Okay, this is just multiplication. Then finally we end up with the input layer. Okay, so this is the general pattern, whether you have a deep network or a single neuron. We always start from the output and then intermediate layers and then input. Okay, so in that sense, if you want to calculate this del Wt, actually you have to calculate as this y hat, right? You have this y hat minus y. Let me just write this. Y hat minus y, and then sigma of x, and then 1 minus sigma of x. You remember this, into x.
Yes, sir. This is with respect to W, I think.
Yeah.
And when we
So
calculate when we calculate with respect to b, there will be no x and last.
yeah.
Yes, sir. So
So
I
so
was
when yes
so there is a confusion, sir, with respect to w or
yes
with
yes
respect to
I just yeah. So when we talk about with respect to this weight update equation, right? No matter whether it's a deep network or a very small single neuron or whatever, if we talk weight updation, right?
yeah.
Then
Yes,
we
sir.
compute the gradient of the weight with respect to the I mean the gradient of the weight means we are computing the gradient of the weight with respect to the loss. I mean how this particular weight actually affects the final loss. So based on that we actually update the parameter, either we increase it or decrease it by a large amount or a small amount. So this is one common confusion that we observe. That might be due to we don't explicitly write something like this nabla. Actually, we have to write something like this: delta, and then small w, and then d something like nabla, small suffix, small w, t, and then l. So this is the entire notation. We are computing the gradient of loss with respect to w, but it becomes cumbersome when we actually for single neuron that is suffice, but when we manipulate for the entire network it becomes too cumbersome to handle. So we assume based on the context we can infer whether we are computing the gradient with respect to for the loss or for are we computing the local gradient. That is the only thing that you have to keep it in your mind. But when we talk about optimization algorithms,
Yes,
no
sir.
matter which optimization algorithm you use, we are talking about the gradient with respect to the loss always.
Oh, okay. So gradient with respect.
Which question?
So so for this answer, sir. So what formula, sir, we will use for particular this answer when we are calculating last?
Uh, yeah, so here we have given you the loss equation as well, right? 1 by 2 minus y hat minus
Yes, sir.
y whole
So
square. Then we have you have to compute this y hat minus y. Then when you take a derivative, this is the same formula that is there in this slide. You take a derivative of L with respect to y hat. What do you get? You will have y hat minus y, right? This 2 and 1 by 2 will get cancelled. So we have y hat minus y. Then you multiply this or you pass this gradient through the neuron. There we have, and which means we take derivative of loss with respect to input of the neuron, which is sigma of x into 1 minus sigma of x. So you compute that value, and then once again you multiply it with the input x. So we have given you this y value, y equal to 1, and also we have given you this x value. And one hint when you write exams, right? Whenever you try to solve the problem, you see all the sometimes the data points may not be make sense, may not be used for that particular problem. But we don't do. I mean, our intention is not to confuse you. Rather, we give you as much details as possible. Rarely we give you more unnecessary details. That is rare, very very rare. But when you look at all these values, you just think of we need to make use of all these value, or you just ask this question: do we need to make use of all these values in order to compute the look ahead? Right? I have given you x equal to 0.5, y is equal to 1, and then initial gradients, right? W0, B0, all these things. Then you might, it gives you a hint that these values might involved in computing the final answers.
Okay, sir.
Yeah, you just look at the formula is there. It's explicitly written in this slide, Aditya, so you can refer to that. I mean, in week 2 lecture, or I don't know whether we repeated here as well. I actually forgot it. Maybe in the first few slides when I hope so, we actually repeated
Yeah,
all
it is
these
in the
formulas.
week 5 also.
Yeah. So actually we started off with reminding all those, I mean, recalling all those concepts, and then come back to this momentum and all these stuffs. Yeah, so it is there in the slide.
Okay, sir.
Yeah, so it's like probably it. Yeah, maybe I can just display it here for your convenience. Yeah, here. Okay, so I would just like to know how many of you are actually, we have created some applets, right? So that you can interact with the applet and learn in case, if you really want to understand the details, you may explore, but interacting with the applets also, you can validate your understanding by interacting with the applet. So that's a main reason why we try to create as much applets as possible. So please do interact with those applets to validate your understanding.
Yeah,
Oh, I think
I'm trying.
I think I just came across this.
Just go down. After this page will come. After this page.
Yeah, here it is.
Yeah, it is here. Yeah,
Yeah,
this
we
one.
use this formula. Yes, previous one. Yeah, this one. F of x minus y into f of x into 1 minus f of x into x. So this is for del w, and then for del b we don't have this x. That's the only difference. That's for bias is not depending on the input to the neuron.
Yes, sir.
And also note that when we have more than one point, we have to sum up the gradient before updating the weight. Okay, so maybe for toy examples, there are many possibilities. So in the graded assignment, we give you one sample and then ask you to compute the gradient for a particular optimization algorithm and ask you to write down or enter the updated value, right? But if we
Yes,
give
sir.
you two samples, right, then and if we ask you to use SGD algorithm, then you have to actually update the parameter twice. But if we ask you to use a batch gradient, then you have to sum up the gradient once and then update the parameter. So these are all minor differences among the existing optimization algorithms, and you try to keep them in your mind because this gives us an opportunity to ask different set of questions, right?
Yes, sir.
And I didn't ask about the quiz. Sorry, I was still unable to interact with anyone of you the WhatsApp. So how was the quiz, by the way?
Yeah.
So were you able to solve? Sorry,
I think it was quite difficult
No.
with respect to graded assignment or practice assignment.
No, it's for me it's not difficult, but I have 2-3 questions, okay, where I have done mistake. I think 4 or 5 questions I have done mistake.
Okay.
I will
Actually,
ask once Aditya will complete. I have some doubt whether my concept is wrong or I have done something wrong. Okay, let him
sir.
finish, then I will ask.
Okay, you can ask. As a question was also very large. Paragraph.
Sorry,
type.
question?
Question was very
Question
large,
lengthy.
lengthy type. There are lots of detail in single question.
Yeah. So the one more reason for those details is that we need to give that. Otherwise, there naturally the ambiguities comes, and we try to avoid as many ambiguities as possible. So we have to give a lot of details. Of course, we thought maybe 1 hour may not be sufficient. Unless someone has a good grasp on all these concepts, they can swiftly start solving the problem immediately after reading the question. But somehow we adjusted the time so that for few questions you can directly answer. It may not even take a minute, but there are some 4 to 5 questions which are not even 4 to 5, maybe 5 to 6, half of the questions which take at least 10 minutes or 5 to 10 minutes. So that might be one. Maybe the next time we adjust these things, and but giving you details is inevitable thing, especially in deep learning.
Okay.
Is it possible? Can you open the Q1 question? Set is this QPF2.
QP, I think I can't display it now, Mukesh, until the quiz code gets released.
Okay.
Because
So
we have the
there's a
questions.
so there's the answer key.
Answer key. I'm not talking about answer key.
Sorry.
Answer,
So there
answer key, which is released by
yes, sir.
on your side.
Answer key is released already.
Oh, they usually release the answer key
Yeah,
immediately after the quiz or after releasing this course.
No. They will release just 1 day after the
Quiz after the quiz.
Okay. So
we know already
anyhow,
our marks. Okay, we know how
Oh.
much marks we are going to get. That's why I'm telling. We know
No.
what mistake we have done. Okay.
Okay, so I anyhow discussed with the COF and other teams, and then I released the answer. So of course, you will get the answer. No worry about that. But maybe okay, you enjoy your Diwali. Then I released.
So answer is already released.
So answer key is already
Already
released.
released.
Okay, so the details are not.
Yeah, details are not there, but I have some questions.
The solution steps.
I have some question on the answer given in the answer sheet.
Okay. So can you share that here then?
But I don't have the access. Can you ask if they can provide, or you can give me the access, then I can share.
Let me see whether I. Yeah. So let me see. Hello. Pardon me. So is it on some other? Do you have it in your kind of? If you share the link on the chat, if I'm able to open
It
that,
is there in.
Yes.
Okay. It's okay.
Because I'm not seeing any options to allow
Okay, let me.
the participants to chat.
So why there is not any practice assignment for week 5?
The reason is it's kind of continuation of week 4. So we have given you enough practice. It's again, once you understand the core of optimization algorithm, right? So the variables involved in all the optimization algorithms, how do you compute all these stuffs? Then there is nothing to give you a lot of questions. So that's why we skipped practice assignments there. Because if you are good at solving questions in week 4, then in fact we actually offered all these optimization algorithms in a single week. That was our original plan. But after recording, right, we just realized that dumping all these in 3 hours is not going to help you either. Just because we have so much contents, we can't record for 4 hours and ask you to listen and digest all those concepts. So we divided it. That's why we didn't give any practice assignment for that one. And we actually divided 2 more lectures that are, I think, week 7 also we divided into 2 halves because there are so much content.
I put it in the link. Can you click it? It will take you to Google Drive.
Yeah, I'm opening it now. It asked me to sign in.
You have to give your ITM ID.
Yeah, let me see.
Just click on the forenoon PDF.
Oh, sure.
And then
it is this one. Okay, so I'm just sharing my screen. Okay.
Click on the FN PDF, right?
Yeah. So forenoon PDF.
The forenoon PDF. Then download this QP, I think, degree one. Which one is
this one?
First one.
This one degree Okay, let me just open this.
No, this is F1. No, other one,
Not this one.
not this one. Yeah, I think, yeah. Yeah, this one.
So questions are different in different sets.
Yeah, we just change the values. It is not kind of totally different questions.
Yeah, just go in the end because the deep learning is in the end of the question.
So search control F. So
Or
search
you can
deep.
put control of deep learning. Yeah.
Deep.
Yeah.
Yeah. Okay. Come down. Down. Oh yeah. Stop here. Yeah.
Yeah.
So in this question, actually, we have given the weight factor minus 0.5 and minus 0.5. Okay. And
Yes.
we have to classify that how many misclassified points are there. Okay. Now, if you see this red dot, which is in the first quadrant. Okay.
Yes.
So if I will take this coordinate, so I know that my X and Y both are going to be positive. The way I have think in the exam. Okay.
Yeah.
So
Okay.
both points are positive. So whenever I going to take this W transpose X, I am going to give a minus value only because minus 0.5 and multiplying with any positive and then adding with minus 0.5 to any positive, I am going to give negative. That means the rate which is given as a rate, it's actually a rate point.
Yes.
In the similar way, if you come to this blue point, okay, and here even it is a negative, but if this negative is more than 0.5, this blue point. So if you take this, consider 0.75, okay, then if you multiply with 0.5, it is coming around 0.35. Okay, that is a positive because plus and minus become plus, and the another points coming as an something like 0.4 or 0.3. If you multiply, it will come some negative, which is less value. That means it's a positive value. That means these 2 points are not actually an error point, but answer is not there. Okay, can you tell me if means my explanation is wrong or correct?
So only 2 points are correct and every points are not.
Okay. So what is the right answer by the way? So it says it's
Actually,
15.
it has to be
15,
13.
13 or 15?
Sorry, it has to be
13.
Okay, so let me explain you the question first and with the
please.
explanation. So of course, you just keep aside all these data points, okay, and let's try to understand this entire line. So the line is represented by minus 0.5 and minus 0.5. Okay, so an orthogonal vector that is pointing in this third quadrant. Okay,
Correct.
so what we are essentially saying that is, I say the class belongs to positive, whatever the data point I take, and then multiply this weight, and if it is greater than or equal to J, we say it belongs to positive class. And then here we are saying the red data points belongs to negative class. Okay, meaning that of course you multiply the data points, and then if it is less than 0, we say it's negative. So what I'm going to do is I'm going to pick 2 points. Okay, because first thing I must know, I have a line, and also I have given, I mean, we are given with this vector that represent line. Now we have to decide which half of the plane is positive and negative. Once I figure out the plane itself, then I need not to evaluate the individual points.
Right. Agree.
Right. That is my first step. Then I take a sample point. So let's say I take this point, 0.5 and minus point. Sorry, this blue point. Okay, you are able to see that, right?
Yeah.
Yes, sir.
We can see.
So I take this 0.5 and 0.5, and then I multiply this with 1. It's minus 0.25 and then minus 0.25, right? So which is kind of minus 0.5. So negative, right?
Right.
Yes, sir.
So which means if this data point is categorized as negative by this decision boundary, then all the points in this entire plane will be classified as negative.
Agree.
The same thing is true for you take any point from here, not necessarily the exact data point. You take any coordinate here, then you do the math. Then it says all the points in this half plane is positive and the other is negative. Then here it says that the positive, I mean the blue data points are
positive,
belongs to positive class, and the red belongs to negative class. Right. Then how many of them are misclassified?
It's 2. No, it's actually 13 misclassified, right?
15.
Sorry, the number of data points that are misclassified, right?
Yes, sir.
So
all the blue above are misclassified and all the red below are misclassified.
Right.
yes, then if you count it, I think it
30.
15.
tallies to 50.
Because what I hear
So-
in the second half, the question is to find what are the correct points. They have given answer to. That's why I asked.
Yeah, so we have to take a different set of questions, right? So say for example, in one set if we ask count the misclassified class, in the other set we ask count the correctly classified points. So that's a norm.
Yeah, that is, but this answer is not correct.
So yeah, and of course, I hope you get this right.
Yeah,
Of course,
no,
this is
our understanding is correct. Okay.
it's similar to one of the graded assignment question or practice question. I don't know.
They did a statement and I asked in the discourse, then you have told that how to check with the data point. I applied the same thing and after 10 minutes, I think that, okay, then I have, as it was 13, then I put it 10 because I know it cannot be 50 because there is no option. So I put it 10 and I got.
So, but
Yeah,
the correct
using
correct
yeah.
answer is 15, no?
No, it should be 13 or 15.
No, total number of points are actually
See, okay, let me
20.
count this. So I'm saying this and okay,
It's a
okay,
15
let's say
total, no?
how many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 17
And
points,
two are,
right? 17
yes, sir.
data points.
Yes, sir.
Then 2 are misclassified, so it's 15.
I
Yes,
counted
answer
the
is-
point wrong itself. Really?
Okay, it's all right. So it happens, but in examination, if it happens, then that's a really a
Okay,
bad
okay,
thing.
then
Sir, please go below.
it's-
So below. So there is a question after 3 iteration. Where will be the line? So below, sir.
This one?
Sir, below. So please go below. I think, sir, this question, this set of questions, sir. All the questions, sir.
yeah, I have
What
also.
will be value of
So yeah,
WT plus 1, WT plus 3? Yes, sir.
Yeah.
This question.
So this is quite, of course, if you are not careful, then there are high chances that you make mistakes here.
Yes, sir. So,
Yeah.
how to,
So
sir?
what's your question, or you want me to explain?
Yes, sir. So how to, sir, solve this question, whole question?
Okay. Then I think
Can
I
tell how I solve it and then you tell me where I have done. I have done in the next two questions. So first question that whether it is a separable or not. So I think it's a separable. We can tell it.
Sir, is there any question related to this question in graded or practice assignment?
not exactly.
No.
Like it's again using perceptron learning algorithm. So maybe we might have asked some question on updating the parameters, but not exactly this question.
But this Mitesh sir has explained this in very detail. I think in full one session.
Yes.
What angles? Yeah.
So, but
Yeah.
Okay, sir.
See, in fact, I took another question which ended up in computing the angle between. I mean, again, here you are doing this computing angle, all these stuffs. But that question, I actually framed that question, but given that maybe students may not have put that much effort to figure out all these very details, so we skipped that. Yeah, this first question is quite obvious, right? I think many of you get this right.
Yes, sir.
The second question, yeah, here you have to be very careful while reading this question itself.
Yes,
so, but the question is clear, right?
Yeah, question is clear.
Yes, the question is clear.
Yeah, so we anyhow randomly initialize the W vector, and then we say we are going to run it for T iteration.
Yes, sir.
The important thing is it considers one data point and updates the weights if required. Okay, because yeah, it's a kind of SGD. Perceptron algorithm is, of course, we can use SGD for perceptron, and this also follows the SGD. And of course, in SGD in general, there will be weight updates. But
Yes,
in Perceptron, weight update happens only if it misclassifies the data points. So
Yeah.
the next line is the weight after t iteration is shown as W2. That is obvious. Okay, we run the algorithm for some iteration, and now we are just displaying the current weight value WT.
Yes, sir.
Okay, then algorithm now starts iterating over the data points in the following order.
DEC.
This is also important, right? So now it is here, then which is the next data point. So it is DEC. This order is important, and you have to keep track of this order. What will be the value of WT after one more iteration? That means we are asking what is WT plus 1.
Yes, sir.
So what you are essentially do is you take this weight, keep this weight vector, and then take the point t and check whether it classifies the data point correctly or wrong or misclassifies it.
Yes.
If it classifies it correctly, then there are no weight update. So the weight remains same. If it
Yes.
misclassifies it, then you make weight update, and then weight gets updated. So you have to enter the updated weight, or you have to choose the updated weight. That's the one iteration, right? So you are able to follow this now.
So we can classify. We can check it is correctly classified or not by multiplying W with X.
Yeah, it turns out that.
So, but
Yes.
what after that, sir?
Yeah,
No,
now
here
this
I think you
question.
need to check the angles, that whether it is a less than 90 or greater than 90. If it is a less than 90, it's a positive count. If it is greater than 90, we have to take as a negative count. For this question, I am talking about.
So can you, sir, please write? It will be more clear.
I think
Okay, so yeah, I have given the details in the solution set. I think probably I released that, but I'm just for the time being, I'm just telling you this, right? So the condition is if W transpose H is greater than
Yes, sir.
equal to 0, then
It
we are
will
setting it
work.
as 1, 0 otherwise. Okay.
Yes, sir.
Then my current WT is minus 1 comma 0.
Yes,
My
sir.
point D is residing at minus 0.5 and 1. So if you multiply
sir.
that, what do you get? Minus 1 into minus 0.5,
Yes,
right?
sir.
The coordinate is plus 0.5,
Plus 1.5. Yes, sir.
and then
Yes,
1
sir.
into 0 is 0. Okay,
Yes,
so
sir.
adding this together is 1.5, so it classified correctly,
Yes,
which
sir.
means at the next iteration, there are no weight updates, WT plus 1.
Okay, sir.
So the weight remains same. So we have
Yes,
to
sir.
choose this minus 1 comma 0. So that is the answer.
Okay.
You
Yes,
should
sir.
not go to the next data point because we are just asking what happens in the next iteration.
Yes,
And
sir.
you are supposed to go through one data point at a time
Yes, sir.
for each iterations.
Yes,
Then the question follows. Then we are asking you to WT plus 2. Now you have to choose the point E. You should not start with D.
Yes, sir.
Then you do the
Calculation.
same computation, and then it seems that it misclassifies, and then you make an update. Then it turns out to be minus 0.5 comma 1. And then with the updated weight, then you do the same step WT plus 3. Okay. Now we have this WT plus 2.
Sir, I think, sir, I actually forget, sir.
Sorry.
So actually I don't get. So I forget how to update, sir, updation part. Can you, sir, please remind? Can you please remind me?
Yeah. Say for example, if my point is positive, right? Let's say I have some weight W and I take some point, and the point is the true label of the point is positive, and then I multiply with this W, and then it turns out to be that it classifies as correctly. Then I leave as it is.
Yes, sir, but
if it misclassifies it, right, which means it considers the point as negative, right? My actual point is positive.
Yes, sir.
But it misclassify my point as negative. Then what should I do? I have to update the weight value. Either I have to add this data point or subtract it. What should I do now? Either subtract or add. In perceptron learning algorithm, there are only two ways. Either you update, add the weight, or subtract. Sorry, add the data point or subtract the data point.
Yes, sir.
Now, what should we do here? Add or subtract?
So we actually, if a point is actually the point is negative, and we got a
No,
angle less
actually the
than.
point is positive, but it misclassifies as negative.
Okay, if actually the point is positive and we got is a negative, so I think we should get a less angle. So we should have subtract the data point,
Yeah,
because
in
for
terms of angle,
positive,
that's fine.
yes sir. In terms of angle, I remember that for positive angle, the for positive data, the angle should be less than
Okay, so what I'm
acute angle. Yes sir.
understand is that you forgot the formula in the exam. That's what you are saying, right? Whether I
Yes sir.
have to
Yes sir.
add or subtract. Yeah, so one thing that you can do is that instead of trying to remember all the formulas, right? Let's say
Yes,
you
sir.
add it. I have given you a reference, W star is there, right?
Yes sir.
So even if you have added by mistake, what would have happened? I actually, after each update, right, perceptron algorithm must move my weight vector towards my optimal solution, right?
Yes sir. Yes sir.
So even if you made a mistake thinking that you have to subtract the weight vector, then
Yes
my
sir.
W2 WT will move away from my W star, which is
Yes sir.
actually wrong. Actually, it has to move close to my W star. By doing
Yes.
that, you can cross check. So these are all, of course, it's very difficult to remember all the formulas. And we give you the formula if it is really difficult to remember.
Yes
And
sir.
if we think that you can figure that out by once you understand the concept, even if you make mistakes in formula, you can figure it out in the examination. Then we don't explicitly give you those formulas.
Okay
Here,
sir.
since even if you made a mistake by knowing that you are moving away from the W star, then you should alternatively you should have added those data points so that it moves towards the W star. So these
Okay.
are all, of course, some expectation from us because, of course, one thing we can't remember everything, but the other thing is some formulas can be derived spontaneously, right? Even not given the time constraint, you can figure out whether the formula is right or wrong after computing that. Of course, if you ask me about the back propagation, if you even ask me that I can't remember the entire back propagation stuff, I won't say you have to remember. Given some intermediate gradient, it's possible to simply compute how the gradient flows across the next layer immediately once you understand that the entire concepts. So again, we emphasize on this back propagation one again and again. You will encounter the same in the ConNet or in the next subsequent lecture. And to each one of you here or who is listening in YouTube, I insist on try to understand the back propagation algorithm. Otherwise, it's quite going to be difficult, right? Of course, getting a good grade is quite difficult.
Yes, yes, agree, sir.
Because we feel that this is an oftentimes every one of us end up avoiding back propagation as much as possible, but we somehow try to pull you in by in forcing you to calculate back propagation values for toy examples. So pay much attention or put as much hard work as possible to learn it. If you have doubt, we are glad to help you out where you are. Once you show us, right, I got stuck at this point, then we help you, or we try to help you by explaining why you got stuck there or what you have understood, wrongly. So that once you make that step, then we can help you. Okay.
Sir, can you go to that question? One thing I need to ask.
Which the same question.
But how, no, next 102, yeah. But how you are going to that point when the weight is updating from the second iteration, it is going to that particular D point.
Sorry, which one, Mukesh?
102, just before that, this question.
So what to add? So how do
This
you
one.
know?
Yeah. So here, how you know that it is going to be minus 0.1, minus 0.5, comma 1?
Yes, the same question, sir.
Because from
Okay. So you are asking how did you get this minus 0.5 comma 1 value?
Yes, yes.
yeah, because
Yes.
it become the weight is coming directly to the what I done in the exam, because I need some 90 degrees, so I have taken in the positive part. So instead of 0.5, I have put it this 0.5 comma 4 point. So it come to the first quadrant, and I will get a 90 degree, less than 90 degrees. And when I see the answer coming to actually on the, I think it's D point, no?
Okay, so I am not. Actually, you have to compute this, right? So keep aside this. Of course, while we make derivation, we tell you that this angle between, I mean, we have this positive half plane and then angle is less than 90 degree, all these stuffs. But when we move in a principled way, when we make use of the data to figure out the right weight vector, right? Especially when the data points are linearly separable, we have to follow the steps given by the algorithm, right? So the algorithm ensures that after classifying every data points correctly, when it comes up with the weight vector such that it classifies all the data points correctly, then this 90-degree principle will work for all the data points. Before that, there are data points which will be greater than 90 degree. Even if you make one more update, then there will still some data points, which won't satisfy this 90-degree criteria. Until we reach this convergence, the data points there will be some data points which are always violating this criteria. So for this particular question, now currently I am in -10 after visiting the data point D, right?
Yes.
Now I have to visit the data point E. Because I'm going over DEC. Now I am, I visit this data point E, which is actually -1 and -0.5. Then I try to classify that data point with the current weight vector, right? So the current weight vector is -1, 0. Then if you compute this dot product, then it turns out that it is, what is that? It is +1, right?
Yes.
Right.
-1 into -1 +1 and then 0. So it's a
0.5
+1, but the data point E actually belongs
To negative.
it's negative, but it classifies it as positive, which means I have to update the weight vector, right?
Sir.
So what do you do to update the weight vector? Either you have to add it or subtract it, right? You have only two possibilities. Either you add or subtract. Now, after, after every update, my weight vector moves towards, this is one right conceptual understanding, that after every weight update, my actual my current weight vector move towards my optimal solution. Okay.
Yes, sir.
So now I have this WT which is -10. Now I have, what should I do? I have to either add or subtract, right? Even I'm not sure. So let me add this. What happens? -1 becomes -2, -1 minus of -1, right? Yeah, -1 minus of -1, which is -1 + 1. Okay, so maybe I write it here. Okay, now my current, why is pen is good? So I have my current weight vector WT, which is
-10.
-10.
Okay, -10, right? Now this weight vector made a mistake on the point E. So what I'm doing is I'm subtracting this weight vector, okay, to rectify this problem. Okay, so what is that vector? -1 and then -0.5, right?
Right, -1 and -0.5 and then 1.
Oh, sorry,
-0.5.
-0.5, exactly is -0.5, and then I'm sorry about this again. So this is 1. So what do? You just -1 plus 0.5 and then 0 minus 1, right? So it is -0.5 plus 1.
Okay, I got it. What mistake I have taken D to C. I read the question wrong again.
So it's minus 0.5 plus 1. Of course, after computing this, you can, with the help of this conceptual understanding, we can plot this vector, so which is minus 0.5 and then plus 1. It actually moved to this point. Now it is moving towards my actual optimal weight, W star. Had I added this vector, of course, I would have moved away from this optimal weight, which should not happen. So this is a kind of check. I mean, cross-checking whether our computation is leading to the minimum, and also while we use this kind of whenever I ask you to compute the or update the weight vectors, okay, you compute the gradient and then you update the weight vector. So how do you cross-check whether the updated value is right or wrong? Even though we don't know for sure for 100%, what we can do is once again we compute the loss, because the network is a very toy network, and then we can compute the loss. And if we have used the GD, say for example gradient descent algorithm, the loss should decrease compared to the previous value. So this gives us a hint that our answer is most probably correct. Maybe we might have made mistake, but somehow we get an idea that our answer is correct. So I request you to do such kind of cross checks before. Of course, well, no matter what you answer, we always have this kind of maybe we are wrong, but doing this kind of cross check stuff at least help us give us some confidence. Maybe our answer is correct, something like that.
Sir. The question was easy actually.
I have taken wrong, sir. I taken
Yeah.
I don't know how I read the question now.
Yeah. So that's why these are all some important. I mean, when we read this question, this is really important. Especially when you give a lot of details, meaning that we give you a lot of details only when we have spotted so many ambiguities. If we forgot to add that information, right? Suppose if I don't mention this DEC, right? You have to follow this order.
Yes.
What would have happened? Just imagine.
lot of different answer will come.
Yeah, no one will. Everyone do the correct calculation, right? Based on their own assumption. They take D, and then once again they take D because I didn't mention it is SGD, and then they take another point C because I didn't mention where should I start. So this forces us to give a lot of details, which means when you see a lot of details, you have to, this is a hint that this question has a lot of details, so there are many ambiguities, so we have to be very careful while you solve this problem. So that is a kind of indirect hint, not indirect, it's a direct hint because it contains a lot of details. So you may follow this template here afterwards. Okay.
Yes.
Then what happened while we reevaluate, all of you are right. So either we have to reevaluate each one of you individually, or we have to drop this question. So of course, dropping is not a good idea, but yeah. I hope once you compute all this weight vector, eventually this is a kind of expected answer. After 3 iteration, eventually you will be close to 0, unless otherwise you compute all this WT plus 3 and see whether they are. And we asked about this angle, not the magnitude of the vector, right? Again,
yes,
they must point in the same direction, so it has to be 0.
Yes, sir.
Right.
Okay, so
when you are going to release detailed solution for this quiz?
Maybe Tuesday or Wednesday. So you are asking about this course?
No, sir. This quiz one, the solution.
Yeah, I will release it on probably Tuesday.
Okay, sir.
Coming Tuesday.
Actually, question has to score 50 out of 50. Okay. Silly mistakes in everything.
Yeah, we have. So far I haven't received your scores. Then after receiving these scores, we may go through all these things and see what are all some common misconceptions. And after having discussion with the prof, maybe we can adjust the scores. I don't know. But while creating quiz question is quite tough for us as well, because we have to think all the possible way that question can be misinterpreted, and then we have to reframe the words. It takes a week to frame the questions, so you have to be extra careful while you read all the questions.
Yeah, no, question was really good, no doubt.
Because we are putting in effort to avoid them. Yeah.
But when you're putting this 6 numbers question, that is actually more time taking and traveling. So you put a 2 6-number question. That is actually you can say in 100 out of it becomes 1/4. So if somehow you get gone wrong, you got the 1/4 marks from there.
Yeah. So and I'm telling you now that for deep learning, right, we are not going to ask you some 20 to 25 questions. We may not go beyond 12 questions, even if it is a 1 hour exam or 2 hour exam. We never go beyond 10 questions, because it's like we want to really check your depth of understanding, especially on some important concepts like backprop. Okay, so we never going to drop this concept backprop, no matter week 4 or week 8 or week 12. Everywhere you see, because it's all going to be neural network, we can take questions from backpropagation. So this is a kind of, I'm telling you directly, you will expect questions from backprop in all the quiz. Okay, and we know that, of course, not. Yeah, Aditya, please do.
Sir, a question was easy, sir, in the quiz from backpropagation, last part.
Yeah, last
Yes, the question was
109. Can you tell me number?
Oh, sir. So yes, sir, this type of
last
is a
question.
question.
This 111. This one. Yeah.
Yes, sir. I was saying that question were easy, sir, from the backpropagation part.
Yeah. Because we have given you the intermediate values, so that's what we want.
Right.
And also we ensure that the matrices are so simple to compute. It's not that we want you to make some intensive calculations, but we just want to ensure that you understand the concept. That's the only thing.
No, it's a well set question, we can say. Whatever mistake we have done, that is a learning curve. We have to learn. Like in this question, I missed minus. Now I'm thinking why I missed minus. 4 5 questions like this I have done wrong.
So I was also going to miss minus, but suddenly I remembered that there was a minus sign.
I don't know how I missed. And there was actually another exam was there for the AI. So I started work and then
so that might be one more
done the mistake, but the time over that time.
So you are all studying so many subjects parallelly, right?
Yeah,
maybe I'm seeing some overlapping between the contents in AI, speech, and DL. Probably this feed-forward network is kind of common across these 3 subjects. Maybe you feel comfortable after a few weeks in speech and AI. Maybe.
Oh. So speech I have not taken. I taken AI part.
Here for so long. Yeah. Silent observer. Okay, Vasistha is not responding. Okay, Aditya and Mukesh, do you have?
Yeah, can you sir go to the week 5? Week 5. I have
week 5. Okay, give me a second. I have to stop share here. Give me a second.
Let me see my understanding where I done wrong.
Okay, where is the week? Yes. Week 5.
Yes.
Okay. Graded as sorry.
Yes, only graded. So in this first question, you have given me a y hat and then you given me a loss function. And also you told that x and y are sparse feature. That means there are a lot of zeros. Okay. Now when I saw the picture, okay, what
yes.
when in this what you are doing, you are giving the W1 and x and W2 and the y axis, and you are giving the loss function as a contour. So what I have done in the way I have think that because if you see in the figure A, the W1s are going in very slow, means you can say the distance between the contour lines are very, very far. That means I can understood that here the x is a sparse. And compared to that W1, W2 is going little bit faster. So that X2 has become as a dense.
No, you got that
No,
wrong.
yes, sir. So I think
So it's
W1 distance
a
is closer.
perceptual problem. Mukesh. The what?
Yes.
See, W1 is actually this x-axis, right? So which means
Yes.
if you really want to see how W1 changes, you have to actually move up horizontally, not vertically, right?
Yes, left to right or right to left. Yes.
Yeah, W1 will go into horizontally, correct?
Yes, sir.
Yeah, if you move, which means if I really want to see how W1 changes, how fast W1 changes, I have on the entire image, you can move horizontally anywhere, okay? Which means if you move along, in parallel to x-axis, you can see the contours are, changing rapidly.
Yes.
Which means x1 is dense.
Yes.
No, you are starting
get
from,
that point,
you are telling from -6, you are going to 0. But if you see from 0 to 6, it has a, you can say, contour lines have a more difference, correct?
No, you just see what happens throughout the entire contours, right? So throughout the entire contours, no matter which area you pick out, okay, so you can't just see two contours or three contours to come to the conclusion that whether x1 or x2 is dense or sparse. Then we have given you the entire range. So if you look at the entire range, so if you move along, if you walk parallel to the W1 axis, you can see that you are seeing a lot of changes in the contours. Of course, there are regions where you encounter gentle slopes. Okay, say from 0 to 1, the slope is so gentle you are not even seeing any change in contours. But after that, once again you see start changing in the slopes. Okay, it's very
There
steep
only
slope.
I got wrong, sir, because when I seeing this 0 to 1, it is a very long distance between. So I thought, okay, this is going to be a spar. Okay, we have to take from minus up to that, and we have to take the majority where the slopes are going, means the contours distance are very, very less. Okay.
So question number 2, sir. Why the answer is false? Because we know that so I think W
So
W2 is
you might have opted this third option, right? Which one you actually
actually,
opted?
sir, I opted for true because in the question it is given that W2 is 0, so there will be no change toward W2. There will be only a line will only go toward W1. Means there will be no W2 direction. So that's why I opt to.
Okay, my W2 can be 0. Initial value of W2 can be 0, right? But after update, my W2 no longer remains 0. It changes, either increase or decrease, right? Even if I given you B value don't depend on my input, but it depends on the gradients. So it keeps updating. Those are all just my initial value. -6,0 is initial value, right?
Oh, sorry.
Yeah, actually the
Yes, it may change, sir, after the iteration, sir.
Yeah.
So there will be not a straight line.
Will not be straight line, and also you might think it is not possible to decide whether the claim is true or false unless you run the algorithm. That is true in general, but for this simple surface, we can see that this trajectory is not perpendicular to all the contours. So in gradient descent, it always move. If you take two contours, and if you are at some point on one contour, then gradient descent always move perpendicular to the contour, right? It's if you look at the intersection of this trajectory with the contours, it's not perpendicular. So this trajectory for sure, I know without running the algorithm that GD won't take this path because the path itself is not perpendicular. So this is actually not covered in the deep learning course, but I presume that since this is so much important concept that might have been covered in the ML course. I don't know for sure. Now I have a chance. Did you study about this in ML course? How the gradient descent moves on the contours?
No,
I don't remember.
Okay, so this is actually an important thing. So
Can you repeat sir once again?
maybe
Perpendicular
you
part.
can, now you can, yeah. It's like, of course I can't, it's very going to be pathetic. Say I have two contours, let's say I have something like this also. Okay. Now let's say I have my initial point is here. Okay, my initial gradient. Now let's say the minimum is here. Okay, and maybe I have few more contours here. Now since I'm here, after updating the computing the gradient and updating the weight, the updated weight or the computed gradient will be perpendicular to this gradient. Okay, because the maximum rate of change happens only along the perpendicular direction between the two conducts. Okay, suppose if I have chosen del WT here, the current gradient here. Okay, what will be my next? Of course, people are celebrating. Okay, then there are so many directions that my next, I mean, in fact, there are 360, not 3, even if you restrict, there are 180-degree possibilities that my next step will be along any of this 180-degree direction, right? But the condition that the gradient should move perpendicular to the contour impose that it should move exactly on the 90-degree. Okay, I think maybe I'm not able to convey this using right words for the time being, but this is a hint. You just study how the gradient move on the contours. Okay, you might have studied about these directional derivatives, right, in MLF. Yeah, we actually while we compute this gradient, not gradient, okay, you just study about these two directional derivatives and the gradient movement on the contours. That
okay,
is,
sir, I will study that.
Yeah, that's of course.
So can you go on the last question?
Of course, for this question, this one is the right answer. It keeps decreasing, but unfortunately, this is not the right answer, by the way. Okay.
Yeah, I'm going to ask that question to you.
Sorry?
Yeah, I'm going to ask that question to you.
Yeah. Sir,
yeah, this one is the right answer.
Yes, I think this one, but I can.
So you are awarded 0 mark for that.
I am getting that upper one because.
Yeah. So we are re-evaluating. So.
No, but
sir,
this one is wrong, by the way.
So this one may be right, sir.
Sorry.
Because this one may be right because if.
Why do you think this is right?
Because in the question it is given that after certain iteration, del W is decreasing.
Yeah, so it is with respect to Adagrad algorithm, right? So in Adagrad, this is my gradient profile. So I run the algorithm from 0 to 100 iterations. Then this is the gradient value I got. Okay. Now I am using Adagrad. What Adagrad does, Adagrad simply squares the gradient and keep accumulating it, right? So whether it is increasing or decreasing, it doesn't matter. So it keep on increasing. So
I understand, sir.
But in case of value keep on increasing. Now I have to. Yeah.
So, but in case of RMS prop,
in RMS props, there is a possibility it increase or decrease.
Yes, sir. Yes.
Since it is about Adagrad, eta will never increase. And in line with the same questions we asked, I mean, the next question is about this one. We choose Adagrad. What is the value of eta? This is for this one for eta 100. So we are claiming whether eta 100 will be greater than eta 6. It is not at all possible. Maybe it can be equal, but it cannot be greater.
Okay.
And similarly, eta 6, of course, for this value, actually we entered 2.2
once again, the question of 5. Eta 100 will be less than, not greater. Yes, sir. I got it.
Yeah, it's false, right?
Yes, it's false.
For question number 4, the correct answer is around some 0.025, something like that. It's not 2.4. It is actually 0.1 divided by square root of 2.4. Okay.
Okay.
I
Again, we
got
are
something 0.06 when I calculated this question number 4.
yeah, it will be around that value only. So 1 by square root of 2.4. So I actually intentionally made this, mistake while I configured this. For my surprise, again, no one claimed that. So in the discourse, there are no debates. I at least expected someone will, jump into that and say, how did you put 2.4 something like that? But
No,
no one
we are
is.
waiting for the question answer to come out, whether what mistake we have done. But sir, can you go to question number 5? When we are doing this Adams,
Yeah.
yeah,
So
Adagram.
this question,
That time this my VT is always going to be the
Increase.
increase, right? So why this n100 will be not greater than n6? Because my n value is also going to increase, correct?
Yeah, see, we are now talking with respect to Adagrad. And no matter which iteration, my Adagrad is going to accumulate the history without giving any weightage to the previous history, right? So what really happens is my VT keep on increasing. From eta 6 to eta 100, there are only two possibilities. Either my VT, now I'm talking about VT, not eta t. So my VT keep on increasing or remains constant, right?
Correct.
So in that sense, if it keep on increasing, I know eta 100 will be less than eta 6. If it remains same, I know eta 100 is equal to eta 6. There is no chance that eta 100 will be greater than eta 6 despite the gradient. My gradient may fluctuate, increase, decrease, or whatever. But my VT remains, or it monotonically increase or remains constant.
Yes,
That's
sir.
the important difference between RMS and what is that?
Adagrad.
Adagrad.
Yes. So can you go to the last question?
Did you get it, Mukesh?
Yeah, I got it.
Okay.
So last question. Last.
7th one, yeah.
Yes, sir. Yeah, this question. So actually I take sir first two option.
Okay.
Because sir in the lecture we see that both MGD momentum and both atom fluctuate around minimum.
Yes.
That's why I take sir, but answer is given wrong.
Yeah, so we can't actually tell that without executing the algorithm, right? So we don't know. I can't simply, unless we have some toy examples, right? Maybe if we wish you to calculate something, we don't give you, compute the trajectory of the entire loss function for various values of rate updates. That's not possible. So that's why we have given to write a small piece of code and verify.
So, but you, I asked in the WhatsApp group that it's first two option is about in general or this particular question. So you reply that it is in general. So in general, sir, momentum and
Did
atom
I
both.
mention that in general? I thought I mentioned just for that particular question, not in general.
Okay, so in general, sir, it will be fluctuate, no?
No, we can't even generalize that because the loss surface it depends on so many factors, especially how the gradient changes, and also in our version of momentum equation, right? Of course, there are different versions of momentum equation where people add this 1 minus beta factor as well and do bias correction. But in our version, we didn't include this 1 minus beta with the current gradient profile, right? And the gradient profile especially decides how the loss, how this entire trajectory is going to looks like. So in Adam, in addition to this, is that
sir,
in addition to this momentum factor, we have this bias correction factor. We incorporate the momentum and also we control the learning rate according to the gradient. But in plain momentum, we don't control the learning rate. We keep the learning rate fixed. So we don't know the behavior of Adam and MGD in general unless we execute the code. It's quite even not possible for simple surfaces.
Hmm. So why
So
there?
you have to write
Why,
a small piece of code and see what happens.
sir? But the actually we have to calculate up to 10th iteration. So
Yeah. After
number.
10,
Yes, sir. So actually after 10th iteration, I calculate and I got the value. So
no, if you exactly calculate for, I mean, at 10th iteration, you might get some minimum value. Okay, you substitute t is equal to 10 and compute the minimum value. Of course, you both Adam and MGD might be close to minimum, but you don't know whether it jumped across the minimum, moved past the minimum before arriving this 10th iteration. It might have jumped across the minimum and come back to
so actually
across
in
this.
this, yes, sir. Actually the minimum the minimum point for this question is 0, na?
Yeah.
So I actually print
That's
all
0.
the.
So it
I
need not,
actually,
it need not. Yeah. Please go ahead.
I actually print all the value
Okay.
for each iteration, but
Okay.
I never cross 0, and
Okay.
I
So you
got
write a code and
yes, I write the code and I actually never cross 0, and also the last value I got for momentum with gradient descent is minus 1.97, and for Adam I got minus 0.99. So actually Adam is more closer to minimum, but I ticked that one, but I got the wrong answer.
okay. So maybe I share my code. I don't know whether I made a mistake, but or otherwise you share your code on the discourse. Okay.
Okay,
Then
so
I look into your code. See.
okay, so I will share that.
Yeah, that is one of the easiest way, because if you have made a mistake, I can point out. If I had a mistake, I can safely hide and re-evaluate.
Okay, sir.
Okay. Yeah, I look into this, Aditya. You just
Okay.
showed your code. No, so you set the
Okay.
initial learning rate to 0.1, right, for both the.
Yes, sir. Yes, sir. I look into everything that is given.
Okay. You share
Okay,
your
sir.
code.
I will. Yes, I will share after that.
Can you go to week 6 practice question? Only one question. That's it. That is last question.
No problem, Dad. Practice.
Question number 3. This is the easiest practice assignment till now. Okay. Yeah. So here you have given one loss function and then you are putting W stars our attention to minima. Okay. So we know if it is a minima, then gradient need to be 0. That's okay. But how the normal loss function need to be 0?
Which one?
The second option is also showing correct. This L W star comma B star equals to 0.
So did I mark this as right one?
Yes.
W star.
Correct.
No, actually for this function, even if you so if you substitute W star and B star, right? So actually, which one is the minimum here? If you look at this surface, right? Or even if you take the derivative and set that equal to 0, you see W star and B star are going to be 0, 0 for this surface.
Yes, sir.
Okay, so if you substitute 0, 0, then it is minus e power 0, which is minus 1 plus 1.
Okay.
That's easy one.
Of course, this added constant makes this difference. It's like because we say the loss is always greater than 0. So we have to add this constant so that the surface itself is always greater than 0.
So you are telling after getting the gradient as we are getting this W star and B star 0, right? But how we know that the W star and B star is going to be 0?
Yeah, for this function.
Optimal. W star B star is actually the optimal point, that minimum loss.
No, if it is a minimum loss,
so there are two ways. Either
gradient need to be 0, right? Gradient need to be 0 for minimum maximum, that is okay.
Yes, sir.
How we know that W star and B star need to be 0? That is not necessary that for gradient W star or B star need to be 0. Then only
so
right.
yes, so there is no coordinate given, sir.
Yeah, no
For
coordinate given.
given.
Correct.
Yeah, so the one thing that you can exploit is that this is an exponential function, right?
Exponential function.
And exponential is monotonically either
Okay.
increase or monotonically decrease, and it is not going to be, unless we negate it, it is going to be positive, right? Now we negate it. So, and we know that, this is one thing I choose this function is this is most commonly used function. We have seen that in a Gaussian PDF or so many times, right? So
Okay,
because
okay,
of this exponential thing, right, and because it's monotonous,
okay.
and there is only one point where we get minimum, right?
Okay,
Of course,
understood. This point is valid. Yeah, that way you can see. Thank you.
Yeah.
Understood, clear. And sorry, one more. The question number 5. So here, as
Yeah.
I explained in the CNN, if we can rotate to not 180, plus minus 10 is okay. Even the
Yes,
cropping is okay. But how this
Yes.
option is correct? Translating image by 1 pixel in all
Yes,
directions.
sir. Sir also mentioned this in the lecture.
Oh, it is.
Yes, sir. Sir mentioned this.
Okay, then I maybe missed this sentence.
Yeah. We got bigger image. Yes, sir. Bigger
Yes,
too.
the idea is that the augmentation should not change the information itself. That's the idea. I mean, you have some image, right? In the name of augmentation, say you have number 6. You say you rotate the number 6 by 180 degree and call that as 6. It doesn't make sense, right?
Yeah,
The
right.
augmentation
That's why option 3 is correct. That's agree.
Yeah, that's the.
But option 4, translating image by 1 pixel. So if suppose A is written in a pixel, if we move everything in A in all the direction, then it will come and put in the same position or what?
No, you're moving the entire A in by 1 pixel, not every pixel in A, right? I mean,
In all direction, it's a shifting actually. You're telling it's a shifting to one pixel.
Yeah, shifting, translating, both I think point to the same meaning. Translate means, of course, we use these two words interchangeably: shifting, translating, striding.
Okay.
Maybe that might have caused you confusion, right? So, which means when we frame next time these kind of questions, we have to give you more details. For you.
No. That's okay. Then only we can ask question to you, right?
Yeah.
That's okay.
Yeah, so I hope you understand this, right?
Yeah, I got your point. And in this last question, the sir has told that when we are putting the drop quality, so in a particular layer it need to be same, right? But in a different layer it can be different. For the dropout regulation, so if we are suppose we have a one hidden layer, suppose 3 hidden layers are there, H1, H2, H3. So for H1 it need to be same. But in
not necessarily, right? So in the lecture, sir has said, for example, in the hidden layer, P is equal to 0.5, in the output layer, it is P is equal to 0.8 something. So that is based on the, vast experiment. After the experiment, they come to the conclusion that if we keep the same probability across the hidden layer, say P is equal to 0.5 is optimal, and the output layer P is equal to, so not the output, in the input layer, 0.8 is optimal. But in principle, you are allowed to set any value. So nobody going to tell you, right, this neuron should have the probability of P is equal to 0.5 always. Even if I have a hidden layer with 1,000 neurons, I can individually set the probability for each of these neurons.
okay.
Especially they are going to be binomial process, by the way. At the end, if you look at 1,000 neurons, then zeros and ones, you are turning it off or on. So it's a binomial process. But you can come up with a different distribution by controlling the p value. For setting 0.5 makes either half of it 0 and half of it randomly, half 0, half 1. But you can set it to 0.2 as well.
Okay.
You can control the individual neuron probability as well. Nothing stops it. That's the message here.
Okay. And the second option, batch gradient descent, cannot be used to update. Okay. That means even the stochastic or even normal gradient also we cannot use when we are using the dropout.
Batch gradient descent cannot be used to update the parameter of the network. No, it should be used. Why did I choose this one?
Okay, no, sorry, it's the wrong option. Correct. It can be
You choose the correct statement. So this
it's
is
correct.
yeah.
It's okay. And the last option, the dropout with p equals to 0.5 act as an assemble regulation. How it is like that? In assemble, we are taking different model, and then either we are putting max, sum, or something, and then we are getting a common model, right? But when it is coming 0.5, so you are trying to tell that it acts as a two different set of models like that.
No. So in general, nothing to do with the probability p is equal to 0.5. You choose any values of p. So once for each iteration, you are dropping out the neurons randomly, right?
Right.
So for each iteration, I have a different models in sense.
Okay.
In a sense, so the ensembleness comes from this picture. No matter unless your PC probability value is equal to 1, you choose any probability value, you drop out neuron randomly. Then for each iterations, the entire network is different.
Okay, then my understanding is correct. I thought that why they put it 0.5 is something special or what?
No, nothing special.
For every case except the p equals to 1, it acts as a regularization. Okay.
Yes, yeah. And even you put p is equal to 0, then finishes.
Okay.
So usually p is between 0 to 1, not exactly 0 or exactly 1.
Okay, that's it from my side. Thank you for your time. It's 2 hours.
Thank you, sir.
And thanks for joining, Mukesh. Yeah, thanks,
Thank you.
Aditya. And happy Diwali once again.
Happy Diwali.
Sir, happy Diwali to you, sir.
Yeah, bye.
Bye.
Okay, sir. Bye, sir.